Very happy to be here at the International Conference on Computational Creativity. So thank you so much. Let me share my screen. I'll be sharing on my study on decentralized indexing in common data environment for collective actions in urban design, a blockchain proposal. Essentially, the study looks at how we can become a peer-to-peer architectural commons. So today's digital economy is dominated by centralized platforms like Google and Facebook. Basically, they offer free computational services in exchange for our surrounding of data, which they then use to control how information is ranked, harvested, and monetized. While they offer a lot of convenience in our lives, including mine, but users actually have little say in where the value of their attention or data goes. Also, not much exists outside the reality of their data management model, which means that very little choices we actually have as service consumers. So in the field of architecture and urban design, decentralization benefit data collection for projects like Sidewalk Lab by Google, which has the ambition to build the next data-driven city. However, as much as they would like to invite citizen participation and their data contribution, the proprietary model often drives public consultation into tokenistic outcomes, and it causes common data environments to remain siloed. What this creates is a serious disconnect between design expertise and real-world community needs, mediated by opaque algorithmic models. Our built environment deserves more inclusive and equitable participatory design methods. And at the core of the problem is the lack of means to collectively discover the value in a piece of information and the ability to collaboratively rank them. So imagine the scenario where you are the architect for a building project. You have collected 10,000 pieces of citizen input and ideas, and you have to search through this data space for the most valuable piece of information that can help inform your decision. The first piece of information that comes up in the search would greatly influence how your decisions are made, but what determines which information came first in the search? For instance, in the example here, data point A and B came up first in my query, and so these two pieces of information will greatly determine how I think about the design process. So this is how information ranking deeply connects to governance and decision-making. Now, of course, we can hire project assistant to rank the information, label them one by one, but we will still run into the problem of defining more subjective parameters that define quality in a design. And also, in the context of a community center, what the assistant perceives as valuable information might not align with what users think, and thus affecting validity in the design decisions. And thus, the decision space. Along these lines, the study investigates two interrelated questions. First, how can value be transacted from peer-to-peer amongst a network of architectural content creators via decentralized indexing? And consequently, how can value be captured and realized within this data transaction, and in what form? Well, essentially, what the study proposes is a decentralized information ranking method, which is essentially a collective indexing infrastructure that turns any data environment into a peer-to-peer system. And the core innovation here is what I call proof of architectural work, POW. And in most decentralized systems like blockchain, a proof of work is a mechanism that assists the community to reach consensus by validating the legitimacy of a computer transaction. However, this heavily relies on whether an individual has the computational power to participate in this mechanism. For instance, being able to purchase a better GPU. This basically means that people with higher financial capacity can more easily influence the system. And while I understand that financial speculation is a powerful tool in the world of investment, when it comes to architecture and habitat building, it can become a problem as excessive speculation can cause damage to projects that should be more human-centric than profit-driven. And so the Powell mechanism proposed in the city tried to leverage the concept that one has to contribute some level of computational power to participate, but still be able to use the power towards enhancing built environment quality. And does so by allowing contributions in forms of urban data points, for instance, OpenStreetMap, LiDAR scan, social analysis, or design ideas, design content like BIM components, graphs, code, or compute like lightweight storage and processing. And so by contributing to the system, it would enhance your stake in the system's decision. For instance, you were able to vote on a piece of information to rank that content, basically generating a decentralized consensus. Or you can earn reward if someone voted for your contributions in data compute or tokens and not just money. So this creates a data for data, compute for compute ecosystem where a network of competing designers, creators, and actors can create harmonious outcomes. Let me give an example of how it will actually work in action. So what you see here is an interface demonstration by 21E8, a blockchain startup. What you see here is that I sent a query to the Omniverse demo chair. And these are the 4 top results that came up. Chair 3 came up first because there are 2 votes represented by the 2 boxes next to it. Chair 2 and 4 came up second, represented by the green boxes next to it. And so I am aware why certain search results came up first as a user. And if you are a creator, what you do is that you basically upload a housing module to this data environment. Backers, like local communities, stakeholders, etc. These are backers. They can vote it up by contributing their spare computing power. For instance, they can store a JSON file locally on their device, basically forming a distributed network of database that is an immutable chain. It's a yellow page of the ranking through the voting mechanics. The vote will influence which result comes up first in the search. And so the creator can attract attention, clients, collaborators, and harness network effect by contributing quality work onto the system. However, that was just a very basic decentralized autonomous organization model. And all of those models are challenged by the same problem of the DAO hack, which are essentially loopholes that let bad actors contribute scam proposals that would eventually drain millions of dollars from the system. And the problem of bad voting is tied to how the community of that ecosystem does not possess enough knowledge required in making valid decisions. For instance, they cannot differentiate between a valid construction proposal with a scam. And that causes the failure of the system through people voting for the scam instead of the valid proposal. Now, the original DAO paper did try to mitigate this problem through a forking mechanism, but in the context of architecture, forking can lead to undesirable outcomes such as property encumbrance. So I argue that we actually need additional mediating agents beside the core agents. The first one, validator. Validator can deploy tools like building information modeling methods to align real-world constraints and test proposals in physics-based properties, thereby validating the proposal. Second, iterators. Iterators consolidate all recorded history of the design proposal, including users' votes, expert evaluation, the beam simulation, and generate evolved design options to achieve a Nash equilibrium, which is an equilibrium by which no actors has the incentive to deviate from the proposal, which reflects a very mature and collectively agreed upon outcome. And finally, and most importantly, perhaps, is the diversifier. So it is not, it is even more important to flood the system with diversified options and valid proposals to increase the probability of successful evolutionary outcomes. So this is what the diversifier does. They take a validated seed idea and deploy differential variables to them and generate exponential amount of options from the seeds. And this is where generative AI comes in handy. Now, I try to demonstrate how this can work. So Hongsuiq is a new development area with a transit-oriented model, which basically means that they focus on connections and logistic networks within the urban fabric. And so it makes a great design case to utilize a graph-based diversifier because it focuses on connections to generate different ways in which urban fabric connects through major functional and transit hubs. For instance, this is a very preliminary test that I did. The following network analysis tried to rationalize the urban fabric with topologies extracted from an E8 graph, a random graph, a small world graph, and a preferential attachment graph. And all of these graphs has different properties. As you can see, they have different degree distribution, clustering coefficient, symmetry, and average path length, which makes them desirable for different planning operations. For instance, E8 is very ideal for conceptual design. They're symmetric, balancing different hubs or nodes in the system. Random graphs are good at modeling unplanned or evolving connectivity. Small graphs are good at optimizing local clusters, and preferential attachments can be used to understand emergence and growth within an urban fabric. And so by utilizing these different diversifiers according to the existing complexity of the fabric, this system can also be used as a datum of evaluation according to predefined project objectives. Now, of course, this test is very preliminary, and I'm sure that computer scientists can do it much better than I do. But essentially, it tries to demonstrate that in an information system, there needs to be entropy calibration. So these are the two elements. The entropy calibration means that validators and diversifiers are not competitors. They're actually competing agents with collaborative outcomes, and they help the system achieve a Nash equilibrium. So specifically, for instance, the AI will maximize entropy through generating options at the interface layer. The BIM will minimize entropy through providing feasibility tests at the address layer. And the blockchain is essentially the manager of entropy by being a directory at the infrastructure layer. So collectively, the system entropy should maximize globally, but minimize locally. And this is how intelligence was defined by Norbert Wiener's cybernetic theory in 1948. And on a practical level, by integrating blockchain, BIM, and AI, it quantitatively eases the influence of bad votes, where AI's big data patterns and BIM's Newtonian physics ground speculation in reality. Now, before I conclude, I would also like to clear a few conceptual ambiguities. These are very important points, or we can refer to them as limitations before future implementation. First, the centralized indexing is not traditional database. There are, in fact, no central database. The index is simply a distributed network of JSON files stored on the community's local devices. It's like a distributed yellow page of contribution. It is not a system for file storage. It only stores metadata like hashes, votes, and the actual data is peer-to-peer. Second, it is important to note that this system, while decentralized, actually has a certain level of centrality designed based on a participatory evidence-driven mechanism to create informed decisions, i.e. user voting and BIM feasibility tests. Finally, the most importantly, how is not a proof of stake. A proof of architectural work is by no means designed to be a financial speculation tool. You cannot buy your way in, because a piece of work in this system is defined to be a piece of contribution in the form of a a design idea, content, or computation power. Therefore, this system has the goal to enhance built environment quality, not profit maximization. However, it does create a computational market that circulate values beyond monetary. For instance, data for data, compute for compute, as each contributing data points or computational power will get in return immediate local resource. For instance, you might get CPU from your peer for your machine learning training. And so to conclude, the study tried to reflect on how value circulates within architectural production on 3 levels. First, technically, it merges blockchain, BIM, and AI into a decentralized stack. Socially, it enables transparent participatory planning and the prevention of bad faulting. Users pay with compute resources per fault, and even though the value is immediate, it tries to raise awareness of their decision and ensure responsible faulting. And finally, economically, it creates a computational data market, not just for capital. And this is more than just a system design. It's basically a shift in the way we think about how values circulate amongst a network of vectors. For instance, designers' model can earn them AI compute time to run simulation. So then we can form a self-organizing architectural commons. To conclude, by democratizing indexing, the study outcome hopes to empower communities to build environments they validate and value, moving towards an architecture of collective intelligence. Indexing isn't just a technical endeavor, it is a significant form of social economic engineering in the information age. So in the next step, I intend to test the proposal using behavioral experiments in real-world community context and try to validate whether my anticipatory outcomes and hypothesized value exchange model actually works the same in reality. I always welcome collaboration, so please do not hesitate to get in touch with me if you're interested. Thank you so much for listening.